let's start with chapter 5. Ne? Let's look at this differentiation. We look at whatever that I'm unable to figure it out now, then please bear with me. Then we'll pack it when we meet next time tomorrow. Then we'll be able to deal with it. Differentiation, slope of a curve, and differentiation. And the other challenge that you mentioned with me is that some of you didn't study maths, you studied maths literacy. So I will not make that assumption because I think on Tuesday, my assumption was that these are some of the things that you already covered in metric and standard 9. Unfortunately, that is not the case. Let's look at slope of a curve and differentiation. Okay. From high school, we remember that the slope of a graph is given by change in y over change in x. Do we agree on that one?
Yes, sir.
Yes, sir.
Yes.
We used to say change in, what did we call? Did we use the word run and then walk, those sorts of things? But change in y over change in x. Change in y being represented by 2 points, meaning we need 2 points to find the slope of a line. You need point 1 and point 2, the coordinates of point 1 being x value and y value. Now, if the first point is point P with the coordinates x1 and y1, the second coordinate, let's say maybe being P what? Maybe P2. If we call the first one to be P1, the next one to be P2, then the coordinates will be x2 and y2. You need 2 values there, x value and a y value for a point. So that's why we are having y2 minus y1 over x2 minus x1. So slope is vertical change of, oh yeah, this is what I was about to say. Other used to say run on the vertical, on the y, and then on the horizontal, others used to say walk. So slope is change in vertical change over horizontal change. Now let's look at this example together. They are saying consider the function. Consider the function y, which is equals to f of x, which is equals to x squared, with its graph shown in figure 5.2. To find the derivative of f of x from first principles, we need to find an expression of change in y over change in x, and then determine the limit of change in y over change in x as x approaches 0. We start with the given function. Given function is y is equals to x squared. And replace x and y with the coordinates of point C. X and y with the coordinates of point x and y with the coordinates of point C. The coordinates of point C, x is x plus change in x. Coordinates of y are y plus change in y. Now y, from here, y equals to x squared. In the place of y, we have got y plus change in y, as we were told that we need to use these coordinates of C. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. In the place of x, we have got x plus change in x. In the place of y, we have got y plus change in y. Here, we are given that y equals to f of x, which is equals to x squared, but y is equals to x squared. In the place of y, we have got y plus change in y, which is equals to, in the place of x, we have got x plus change in x, everything raised to the power 2. Now, from there, then, we have got x plus change in x to the power 2. Now we expand the right-hand side. Do we agree?
Yes, sir.
Okay.
Yes.
Do we agree? Please, maths, we don't work out maths exercises by inspection, but we work. Now, who? Collins. Collins,
Yes, sir.
do you agree that x plus change in x all squared is the same as x squared plus 2x change in x plus change in x squared? When we subtract y, which is equals to x squared from both sides of the equation. Now let's try to understand what is it that they are saying here. They say they need to subtract y from both sides of the equation. And why? Okay. Why are these people doing this? When we subtract y, which is equals to x squared, from both sides of the equation, we find, okay, from here, from this equation that I've highlighted, we have got this first y. We agree, yeah? We have got this change in y. Now they are subtracting this y. We subtract y, which is equals to x squared. I think the idea is to can be able to get rid of the y. From here, from what they have here, from the beginning, we know that we have got y equals to x squared. Are we in agreement? Now, when it comes here, in the place of y, where they see y, they are putting x squared, if that is the case. But now, this part, it is this one. Where, okay, I agree with this statement, the one that I've highlighted. In the place of y, they put y plus change in y. In the place of x, they had x plus change in x all squared. When we expand this, I think Collins agreed that we end up having x squared plus 2x change in x plus change in x squared. But now when they say, what are these people saying? That's squaring left, right, or the right-hand side. Yes, we end up having this. When we subtract y, which is equal to x squared, from both sides of the equation, y, this part remains. This one is, they are subtracting this y. Where is this coming from?
So, I think it's coming from the initial statement where it's saying y is equal to x squared. So if
X
it's minus y at the end of the initial statement on the left-hand side, then it's actually going to equal to minus x squared, since y is equal to x squared.
We subtract y, okay? Which is equals to x squared. All right. On the left-hand side, they are subtracting with y. Are you saying from this bracket where they are saying y equals to x squared, then on the right-hand side, instead of subtracting y, they are subtracting x squared?
Yes, sir.
Yeah. I think it makes sense. Because now it says subtract y from both sides.
From both sides, yes.
Yeah. So that's why
And
they
then
put the negative y on the left hand side, and then they put the negative x squared on the right hand side, because it's the value of y, which we have to subtract on the right hand side and the left hand side.
I'm with you there. Okay, maybe we'll get to see why in terms of what is it that they are trying to achieve. Okay. From there, then what is it that they're doing? Change in y. Okay, this y will cancel with this y. Do we agree? This x squared will cancel with this x squared. On the left-hand side, the y will disappear. Do we agree?
Yes.
On the right-hand side, the x squared will disappear.
Yes.
Then on the left-hand side, we'll be left with change in y, which is that one. Then
Yes.
on the right-hand side, we'll be left with 2x change in x plus change in x squared. Okay, this is what they are left with. Now, they are saying dividing by change in x on both sides of the equation. Change in x on both sides of the equation. Now, on the left-hand side, it will be changing y over change in x, which is equals to 2x plus change. Okay, because this is change in x times change in x divided by change in x. So change in x will cancel with another change in x. So we'll only be left with one change in x. Do we agree? Yeah, up to so far?
Yes.
Okay. I'm still trying to find the logic of what is it that they are intending to achieve. Now they say when change in x now becomes smaller and smaller, meaning it tends to 0, we find the derivative to be change in y over change in x is equals to the limit of change in y over change in x as x approaches 0 to be equals to the limit of 2 of x plus change in x as x approaches 0. Now, the slope of the curve y equals to x squared is called its derivative, and is called its derivative, n is given by dy dx, which is change in y over change in x, which is equals to 2x. Okay, that's simply the basic. In other words, what these people are saying, they are saying, in order to find the derivative, if you are given x squared, okay, and then you are required to find the derivative of x squared, please write down this. If you've got x squared, if you've got y is equals to x squared, and then you are trying to find the derivative of y squared is dy over dx, or alternatively, as it has been written here, you see here they said y equals to f of x, which is equals to x squared. You can say dy over dx is equals to x squared, or f of x equals to x squared. Then this f prime of x is representing the derivative of x squared. How do we find the derivative? Let's say in this case, we have got y equals to f of x, which is equals to x squared. In order to find the derivative of x squared, what you do, what is the power of x? What is the power of
2.
Is 2. You bring that 2 in front of the x, okay? Then on that power, you subtract 1. So the derivative of x squared, it will be 2x. Okay? Are you with me?
Yes.
Yes, sir.
Yes, sir. Now let's say we have got y equals to f of x, which is equals to x to the power 4. What will be the derivative of y equals to f of x, which is equals to x to the power 4?
It will be 4x.
Sorry?
Or it will be 4x to the power of 3.
Yes. You take that 4, you bring it in front of x, and then from that 4 at the exponent, you subtract -1. So it will be 4x to the power 3. We agree? That is how we differentiate. Now, here they say, by using this formula, we can find the slope of the curve at any point on the curve. Examples. At x equals to -1. All right. This is what they are saying. The derivative of x squared is 2x. Do we agree from here? From this line?
Yes, sir.
The derivative of x squared is 2x. What they are simply saying here is to say, in the derivative, not in the given function, in the derivative, that's where they are substituting what? These different values. That's why they are saying at x equals to -1. Okay, now, Michelle.
Yes, sir.
Yes. Now, you and I agree that the derivative of x squared is 2x, okay?
Yes, sir.
Now, these values that they are talking to us about, here they are talking to us about these three values: x equals to -1, x equals to half, x equals to 2. These values are the values that are being substituted where? Not in the original equation, but in the derivative. The original is y equals to x squared, né? And the derivative of y equals to x squared is 2x. The derivative of x squared is 2x. Do we agree, Michelle?
Yes, sir.
Here is my request to you, Michelle. When you put -1 into x, what do you get?
-1 into x.
Then what do you get? Whenever
1.
you see x in the derivative, you put that -1. What will the answer be?
So it'll be 2x minus 1.
Which is?
1. Or just x.
Michelle?
Yes.
Our derivative. We
Yes.
found the derivative of x squared to be 2x. Okay.
Yes.
We agree, you and I, né?
Yes.
Yes. Please write it down. Here is the derivative. Whether you write it in this way or in this way, is the same thing. Whenever you see x, you put -1. Here, use this. Whenever you see x, put -1 and tell me what you get.
Can I
As the-
try to answer just for my sake of seeing if I understand?
Yes, who's talking?
Moleman.
Mlemani. Yes, Mlemani.
Okay, should it be f of x is equal to -2 if we replace x by -1?
Yes, I agree with you, Mlemani. When this is just saying at x equals to -1, in the derivative, where you see x, put -1. That is what it's saying. You see here. Do you see here? Do you see this f here? F prime of x. It is this. F prime of x is equals to 2x. So now, f prime of 1, in this x you will put 1. Then, you will put -1 here. Then you come to the right-hand side. Whenever you see x, you will put -1. Then you will end up having -2. What at x equals to 0.5, what do we get? What will we get?
Okay, I'm gonna say 2 times 0.5. It's gonna be 1.
Without using a calculator, Margaret, what is 0.5? If we don't have a calculator, what is 0.5?
0.5 is 1.
0.5 is?
1.
No, Margaret. 0.5 is 1 over 2 if we are not using a calculator.
Yeah, you're correct. It's 1 over 2, it's half.
Yes. In the derivative, whenever we
Yes.
see x, in the derivative, whenever we see x, we'll have to put 2. What will the
Yes.
final answer be?
4.
I agree with you. Do you see it?
Yes,
How
I
it
do.
comes? How
I
it
do
comes
see.
to be 4?
Yes, I do.
Okay, thank you. Here they are saying the derivative of a function gives the rate at which the function is changing at each point on the function. Okay, tells us at x equals to minus 1, the derivative is minus 2. Where x is half, the derivative is 1. Where x is 2, the derivative is 4. Now, let's talk about the differentiation rules. The process of finding the derivative of y with respect to x, denoted by dy over dx, is called differentiation. In the following sections, we discuss the different rules for differentiation. Now, the first one, the power rule for differentiation. The power rule is the basic rule to determine the derivative of x to the power n, where n may be any real number. The power rule states the following. Okay. If y is equals to f of x, which is equals to x to the power n, then the derivative denoted, you see this f, then there is an apostrophe in front of f. Hello?
Yes. Yes, we see.
we can.
Yes. That apostrophe is representing the derivative of f. Are we together?
Yes. Is this the
Yes,
first
sir.
derivative?
Sorry?
I was asking, is this the first derivative?
This is the first derivative, yes. This is the first derivative. If it's the second derivative, it will be 2 of those apostrophes. But since we are studying, we are dealing with the first derivative. Okay, please don't be confused. If you see that f prime of x or you see dy by dx, it means different. This f prime of x, meaning is the derivative of f with respect to x. Dy over dx means y is being differentiated with respect to x. It comes back to what we said, what we just spoke about in the previous example. This is what they are saying. Do you see x? Do you see y, which is equals to f of x is equals to x to the power n? Now, what is the derivative of x to the power n? You take that n, you bring it in front, and then to that n, you subtract minus 1. Is this not what we did in the previous example?
Yes, it is, sir.
That's exactly what we did.
Thank you. Now, they say, consider, for example, the function y is equals to x to the power 5, or f of x equals to x to the power 5. Do we agree that this is just one and the same thing?
Yes, sir.
Yes.
Yes, sir.
Thank you. Now, they are saying, in this case, n is equals to 5. So, according to the power rule, this is the power rule. You see this? What is in this box is the power rule. Particularly this is what they're referring to as the power rule. Now, in this case, n equals to 5. So according to the power rule, we'll just take this 5, we bring it in front, then to that exponent, then we subtract -1. Okay? Here they say dy by dx, the derivative of y with respect to x, meaning we're differentiating y with respect to x. Okay. Y equals to x to the power 5. We take that 5, we bring it in front. And then to the exponent, we subtract -1. We end up having 5x to the power 4. We have differentiated, we are done. You can write it in this way or in this way. Following additional rules are applicable when working with the power rule. The following what? Additional rules are applicable when working with the power rule. Now, they're saying when a mathematical term is multiplied or divided by a constant, the term is differentiated and then multiplied or divided by the constant. They say for any term of the form k x to the power n, the derivative is you take the k, you bring k, you leave it as it is a constant, you leave it as it is, and then you take that n, you bring it in front of x, and then you subtract -1 to that power of n. Are we together here?
Yes, sir.
Yes, sir.
Thank you. Now, let's look at this example. They say the constant k can be positive, negative, or a fraction. D by dx, meaning the derivative of 10x to the power 3. How do we differentiate this? 10 is a constant, okay? You leave it as it is. You differentiate this x to the power 3. How do we differentiate that? You take the 3, you bring it in front, then to that 3 in the exponent, you subtract -1. Then we end up having x squared. Then we end up having 10 times 3, x squared. Any question on this one?
No, sir.
No.
No. Now, let's look at this one. This one. Here, we have to find the derivative of -3x squared. We do the very same thing. -3 is a constant. What do we do? X is raised to the power 2. We take the power, we bring it in front of x, then we subtract -1 to the power. So we end up having -3 times 2, x to the power 1. Then we end up having -6x. Are we in agreement?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. Now let's look at this last one. They say we need to differentiate. We need to find the derivative of half of x to the power 5. How do we do that? Half is a constant. You leave half as it is. You bring 5 in front of x. Then in the exponent, which is 5, you subtract -1. Now, when we do that, we will have half multiplied by 5, x to the power 4, which is the same as 5 over 2, x to the power of 4.
Sorry, sir, just a question.
Yes.
So if we say you bring the 5 in front of the x, right? And then you have 5x4. Are you subtracting the 1 from that x? Are you saying then because you are bringing it down, you always subtract 1, same as the previous one, where you said when you bring down on the first one, when you said you bring down the 3 to be 3x squared, did you subtract because of the x? So every time you bring the that numerical figure down, do you subtract the 1?
From the exponent.
Okay,
Yes.
thank you.
Who's talking?
Sorry, it's Buhle.
Butle. It is not me, and it is not witchcraft. Ne? It is this. This. Do you see this?
Okay,
Do you
okay,
see the
yes.
cursor? Do you see this
Yes,
cursor?
okay, okay.
Yes. Now, let's continue. They're saying the derivative of a constant term. The derivative of a what? Constant term is 0. Now, this is what they are saying. A constant like 5 can be written as 5 times 1, which is also equals to 5 x to the power 0. Okay, now I need to talk to Dikezo. Dikezo,
Yes, sir.
what is 100 to the power 0?
It's 0. Wait, sorry. 100 to the power of 0 is, I think it's 0.
David, thank you, Dikezo. David, what is 100 to the power 0?
It's a balance.
Sorry?
So I think, so this is Colin speaking.
I can hardly hear you, brother.
Sorry, am I audible now?
Yes, I can hear
Can
you.
you hear me?
Yes, I can hear you.
Anything to the power of 0 is equal to 1.
Thank you, brother. Please tell the kids.
Oh, yes, sir.
Because
I now remember. Sorry.
Okay. Thank you. That is why here we have got x to the power 0. Okay? X to the power 0 is the same as 1. Anything to the power 0 is 1. Do we agree? Here, this is what they are saying. They say because anything to the power 0 is equal to 1. Okay? Now, the derivative of 5 is therefore 5 x to the power 0. Therefore, then, to that power of 0, okay, let's look at it in this way, the way they are looking at it. Take 5. Okay, let's start here. Take 5. 5, then d by dx means differentiate 5 with respect to x. Are we in agreement? D by dx. If we have got that 5 and then you have got d by dx in front, that means differentiate 5 with respect to x. Okay, that is what that stands for. But because we are not having an x there, that's why then they are saying 5. We know that 5 is a constant. Okay. Do we agree that 5 is a constant, or do we not agree?
It is.
Yeah, agree, sir.
Is it a constant?
Yes. I have a question,
Yes.
On the statement which says anything to the power 0 is equal to 1. This can be any number. If, let's say, we say 0 to exponent 0, is it still 1?
0 to
exponent 0.
Now that is a different thing. My brother, we are saying because anything to the power 0 is equals to 1. Anything, any. Okay. That is interesting. They are saying what? anything. Anything, even including 0. Okay. Including 0. When we say anything, do we exclude 0? Do we include it?
I'm not sure. That's why I was asking, because I know we can include negative numbers. We can include
Yes.
positive numbers. However, the 0, I'm still not sure.
Yes. Can anything. 0 to the power 0, it will still be 1.
No, so it's undefined.
Is it undefined? Undefined, I know that the situation where we are having an undefined, the only one that I'm aware of is where any number is divided by 0. That is undefined. 100 over 0, Faima, what is it? What is 100 divided by 0?
It's 0.
What is 100? Write it down. 100.
100 divided by 0.
Divide by 0, yes.
But you can't divide by 0. So isn't it then 1?
Okay, what is your answer? 100 divided by 0, Butle? From your side, what?
I would say it's 0.
You'll say 0. Okay. Michelle, please ask your sister Michelle to help.
It will be undefined.
Michelle?
Yes, sir, it will be undefined.
Please tell Butle.
It will be undefined.
So it's undefined because you can't divide by 0.
Yes.
How Marase, I was right, Mas.
You were right when you said
You can't divide by 0. Technically.
Technically you can divide by 0, but then you said to me your answer is 0. That's where I disagree.
It's just technicality. But I hear you say it's undefined.
No, mathematically it's undefined. Okay,
Noted.
Butle, while you are still on the floor, you and I, let's take this further. What is 0 divided by 100? Oh, okay, hang on, Butle. What is 0 divided by 150?
It's 0.
0 divided by 1,000?
It's 0 because now you are not dividing it. This is my thinking. Because now, initially we were saying that number, so 100 as an example, divided by 0, you can't divide it, right? You can't divide by 0, meaning it's undefined. But now you are saying 0 divided by whatever number, then it becomes 0.
We agree now.
Okay.
0 divided by any number is a 0.
Thank you.
Thanks. Now, here, we are now here. They are saying 5 is a constant, but is being differentiated with respect to x. Now they are having that x to the power 0. You bring the 0 in front of x, okay? Then you raise x to the power 0 minus 1. I'm posing this question to the two of you.
Okay.
We have got x to the power 0, okay?
Yes.
We need to differentiate this x to the power 0. When we differentiate, we will take that 0, which is an exponent, we'll bring it in front. Do we agree?
Yes.
Yes, sir.
And then to that 0, then we'll subtract -1. Okay.
Yes.
Then
Yes,
what
sir.
do we get? What do we get
You
as an
get 0.
answer?
You get 0, sir.
Please talk to your partner.
Oh, Mr. Collins, we get 0 because anything multiplied by 0 is 0.
Yeah. No. X, wait, you're saying 0 times x. At the end, the thing will be 0 times x to the power -1. That's the whole thing. And then you're saying
Yes.
it's going to equal 0 because any number times 0 is equal to 0.
Yes.
Yeah.
But now you're going to times the whole thing with 0. So it's still going to be 0.
Yeah. I agree.
Okay. Then I agree with you. That is why then we end up having 0 there, because anything multiplied by 0 is 0. Thank you. Let's continue. The derivative of a polynomial y equals to f of x, which is equals to a, x to the power n, plus b, x to the power n minus 1, plus up to plus c, x squared, plus d, x to the power 1, plus e, with a, b, c, d, and e being constant, is the sum of the derivatives of the terms. That means in the polynomial, a, b, c, d, and e are constants. Now, let's look at this example that they are sharing with us. They're saying, they are giving us this polynomial which is inside the bracket, which is x to the power 4 plus 2x cubed minus 5x squared plus 3x plus 100. This polynomial inside the bracket is differentiated with respect to x. That's why we have got that d over dx. We usually say d by dx. How is it differentiated? Okay. Every term is differentiated with respect to x. That's why you have got d by dx in front of every term, d by dx in front of x to the power 4, d by dx in front of 2x to the power 3, d by dx over d by dx in front of minus 5x squared, d by dx in front of 3x, and positive d by dx in front of 100. Now, Margaret.
Yes, sir.
What is the derivative of x to the power 4?
It will be 4x to the power 3.
Thank you, Margaret. Shireen. Is Shireen here? Okay.
No, she's
Michelle.
not.
Okay. Let me cross out Shireen. Michelle,
Yes, sir.
what is the derivative of let me take it slowly with you. What is the derivative of x cubed?
2x to the power of 2.
Please repeat.
2x to the power of 2.
Shireen, hang on. Please, let's hear each other out clearly. What is the derivative of x to the power 3?
2x to the power 2.
No, you are not hearing me out. I just give you y equals to x to the power 3. Okay. And I'm saying, please find the derivative of y equals to x to the power 3. What would it be, Michelle?
I'm not sure, sir.
Using the power rule. Take it easy. Easy. Okay. Michelle,
Yes, sir.
don't panic. Now, there is something that you need to bring in front. And then to that something you need to subtract 1.
My apologies, I was saying 2, but it's supposed to be 3.
So what would it be?
3x to the power 2.
Thank you. Now, in this expression, do you see that we have got 2x cubed?
Yes, sir.
That's why I said I need to take it slowly with you. So now you and I agree that the derivative of x cubed, it will be 3x to the power 2. We agree, no?
Yes. Yes, sir.
So that means that 3 will be multiplied by that 2, which is available there.
Yes.
Thank you. Collins.
Yes, sir.
My brother, what is the derivative of x squared?
The derivative of x squared is 2x.
Hmm?
The derivative of x squared is 2x.
Is 2x, eh? We agree, no?
Yes, sir.
But then, in this given expression, in front of x squared, we have got -5. Do we agree?
Yes, sir.
So, do we agree that that 2 will be multiplied by that -5?
Yes.
Thank you. Molemani,
Yes, sir.
brother, what is the derivative of x?
It should be, I'm not sure. It should be x or 1.
It can be this or that. It has to be one number.
It's x, so it's x. So when you x originally it has an exponent to 1. When you bring the exponent 1, you multiply it by x. It's still x.
Malaman, please write x on a piece of paper.
Yes, I'm doing it now.
To that x, please, okay, let me rephrase what I just said. Please write x to the power 1, because x is the same as x to the power 1. Did you do that?
Yes, sir.
You wrote x to the power 1. You and,
Yes.
okay, first of all, you and I need to agree on something. Do you agree that x is equals to x to the power 1?
Yes, that's exactly what I said. So there's a power 1 which is not mentioned.
Yes. So now that's why I'm mentioning it.
Okay.
So x is the same as x to the power 1.
Mm-hmm.
Now I'm asking the derivative of x to the power 1. What is it?
Since it's 1, it's 1. So there's only one x, so it's 1.
It's 1.
Yes.
Okay. Please explain to me how you will get the derivative of x to the power 1 before I can agree or disagree with you.
Okay. So there's x.
In other words, what I'm requesting you to do is to explain to me what is it that you will do to get to the final answer when you differentiate x to the power 1.
Okay. So there's x, right, which already has a 1 on it. So when you take a 1 down and you minus a 1, you'll be left with 0, right? then x to that exponent is 1.
X to which exponent, my brother?
X to exponent 1 minus 1 is 1.
What is 1 minus 1?
It's 0.
So, Muleman, Muleman, that is what I'm expecting from you to say. X to the power 1 minus 1 is the same as x to the power 0. Therefore, x to the power 0 is 1 because any number to the power 0 is 1.
Yes. You know, when it comes to that one, I don't know. I don't want to agree with that statement because, yeah.
It's not me. That's how it is. Any number to the power 0 is 1. But then, if we're having x, we know that any number, let's use your, I think it's Muleman, is it your name or your surname?
It's my surname.
Okay, it's your surname.
Yes.
Now, your surname is Mulemani.
Yes.
Are you aware that your surname is raised to the power 1?
Yes.
Are you aware that your surname is divided by 1?
Yes.
Okay. Then you and I then shouldn't be having any problem. If we agree that your surname is raised to the power 1, then we're getting somewhere. And again, if we agree that your surname is divided by 1, then we're getting somewhere.
Yes. Yes.
Okay.
You know, the thing, the argument which I was trying to push on my side was since we don't know the real value of the base, if x to the power 0 is 1, if we replace x by the real value of x, let's say the real value of x is 0, then what happens? Is it still 1?
No,
that's the argument that's where I was taking the argument.
No, hang on, my brother. Here, now you are talking about two different things. In this case, we are saying we have got x, and this x is to the power 1. Okay. This x is our base. Our exponent is 1.
Yes,
if
sir.
you remember, there are those laws of exponents. You still remember them, or did you not come across them anywhere?
I did when I was in matric.
Now you are making my day now. From those laws of exponents, any number to the power 0 is 1. Now, this x, even if they don't write that 1, but when you differentiate, you know that x is to the power 1. So when I differentiate, I'll bring the 1 in front. To that 1, which is an exponent, I will subtract another 1. So it will be x to the power 0. X to the power 0 is 1, then multiplied by the 1 in front.
That's
Are we
true.
together?
Yes, yes.
Thank you. Now let me go and talk to David. David? David? Is David still with us?
No.
Dikezo? He left. Dikezo?
Yes, sir.
Yes. How are you, my sister?
I'm okay. How are you, sir?
I'm good. There is that number, you see in this expression, there is that last number. What is it?
100.
100. I'm requesting you to find the derivative of 100. And then after giving me an answer, I will request you to explain to me how you got that answer.
Okay, sir, what I know is the derivative of a constant is equal to 0, and we don't write it.
Thank you, my sister. I agree with you. Then that's why then from what everybody has said now,
We've got a new guy. We've got somebody. His name is Danielo George Reid.
Danielo.
D'Angelo.
D'Angelo.
It's
Sorry.
D'Angelo. No, don't worry.
Sorry.
Don't worry. But yeah, sorry, I was gone for a minute because I had to fetch something, but I'm
Oh,
back
okay.
now. Sorry about that.
Welcome, D'Angelo.
Thank you.
Now,
Thank you.
all of you, do you agree with this, let's say 1, 2, 3, third step of saying the derivative of x to the power 4 is 4x cubed. The derivative of 2 times the derivative of x cubed is 2 times 3x to the power 2. And then minus 5 times the derivative of x squared is minus 5 times 2x. And 3 times the derivative of x is 3. And the where is that 1 coming from now? Okay. Who was I talking to lastly? Dikezo?
Yes, sir.
1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, okay. All right. No, I see. Dikezo, we agree that in this third step, that 0 is no longer there, né? Is the one that you indicated that the derivative of 100 is a 0. Do we agree?
Yes, sir.
Then after multiplying and simplifying, we end up with what we are having in the last step, né?
Yes.
Do you agree with that? To say that that last step is the derivative of what we have been given?
Yes, I do agree, sir.
Please ask amongst us, anybody, if they all agree that this is the derivative for that x to the power 4 plus 2x cubed minus 5x squared plus 3x plus 100. Please ask them if there is anyone who disagrees so that we can explain before we continue.
Is there anyone that don't understand how we came to the derivative?
Yes, sorry, sir. So in that plus 3 times 1, where does that 1 come from now? Because if we say, like Dikezo said, it's 0, but now on the next step, they've got that times 1.
Oh, can I explain?
Here's the Dikezo.
Obviously there's a 1 next to it's the 3x's to the power of 1, right? So when you say 1 times 3x is equals to 3x.
3x.
The one that is there already minus the 1 is equals to 0, right? And then anything to the power of 0.
0 is 1. Okay.
So the 1 that is left is of the x. I don't know if I'm making sense, but I think I know what I'm talking about.
That sounds a bit confusing.
That was Dikezo and who? Hang on, who was talking to Dikezo? Dikezo, who are you explaining to?
It's Butle.
It's Butle.
Yes, Butle. Please make sure that you understand. Do you understand what Dikezo is saying?
Yes, I carry the constant 3. 3x,
yes.
right?
Mm-hmm.
Then she said...
Whoa, Butle, please, let's be careful. Please start from the beginning. Let's say I didn't hear what you just said, because you said something that you were not supposed to say there. Okay, start.
Now you just made me lose it completely.
Don't lose it. You said something that you were not supposed to say it.
Okay. The in the initial step on top, 3x in that bracket, right? We take the number 3, we bring it down. It becomes it's not a, it's a constant, Takir.
3 is a constant. Now
Yes,
you are
the
talking.
3
3 is a constant.
becomes a
we bring
constant.
it in front. We bring it in front.
Yeah, and then in brackets it's that x, and then it's plus 0. Now, Dikwetu was saying anything that is to the power of 0 is 1. Meaning that 100 that we got there, if we bring it down, no. I think Dikwetu must explain again.
Dikwetu, please explain. If Butle doesn't understand, then I'll come back again. Okay?
So I must explain why the 100 is a constant and why you can write it.
It's a constant because you bring it down.
No.
Just like we did with the 3.
Okay.
But because it's a numerical value,
let me make
we don't
an
write
example. Ne? So right now, can you see the answer that we got there? Like the 4x to the power of 3.
Yeah.
Do you know that if we derive at the end, the 3 won't be available because it's a constant? If we derive again, if we were asked to derive the answer,
to derive further, yes.
Do you know that we won't
bring
be
it
able
down
to
again,
derive?
yeah?
We won't be able to derive the 3 because it's a constant. Anything that doesn't have like an x.
The x, yeah.
Yes, you can't derive it because it's a constant number.
Okay, I get it.
You get it? So you can only derive anything that has an x or a variable, let me say.
Yes.
Right? So even you can only derive until 10x if we were asked to derive further. So the reason why I'm saying 100, we cannot derive 100 is because 100 is a constant. Yeah. So you want to know the 3x?
Yeah, so the 3x, you bring down the 3 because the 3 is a constant.
Yes. So basically, derivative, differentiation is like you are trying to break down.
Yes.
So I don't know if you can see that anything that we are doing here, we are trying to reduce something. Can you see?
Yes.
So yes, at the end, that's what we're trying to achieve. So the 3x, we use the power rule also, right? Even though we don't have an exponent, we still take 3x to the power. We still take 3x and then we put 1 on top because we are trying to differentiate, right? So 3x is going to be 3x to the power of 1. So we multiply the 1 with the 3, right? It's going to be 3x, right? Then you say the 1 minus 1 at the top, it's going to be 0. Anything to the power of 0 is 1, right? Then the 1 multiplied by the 3x. The 1 multiplied by the answer there is going to be 3.
Yes, okay.
You get it?
I get it, sir. I just needed to sink in, but I hear it. Thank you.
Okay.
Butle.
Yes, sir.
My sister, this is what we are saying. Take 3x, okay?
Yes.
Okay. Please write it down. Write 3x. Did you write it?
Yes.
Now, you and I, let's find the derivative of 3x. When we find the derivative of 3x, the next thing that we'll write, in the next step, we'll write 3, okay?
Yes.
Then we'll write d over dx, okay?
Yes.
We'll open bracket, then x. Close bracket.
Yes. Yeah.
The next step, then we'll write 3, okay? What is the derivative of x?
Is 1.
How? Explain to me that part. If you can explain that part to me, then I'll be convinced that you do understand.
Oh, I just know it's one, Sene. But that's why I'm saying I'm just trying to get it to sink in. Can I come back to you a bit later?
There is no later.
With a reasoning.
The time is now. Okay, let's do it together. Okay. I know maths is. Did you do biology?
Years ago. Yes.
Yes. Yes. At least you and I are agreeing on something. Biology. There is that subject that is called biology. In there is that process called osmosis. Mathematics, we don't learn it by the process of osmosis. If you don't understand something, leave it. Come to it at a later stage. If I hear you when you say it is not making sense, you need it to sink. But at this point in time, I hear you and understand you. But we just don't have time for that. Okay? That's why I'm requesting to show it to you now. Okay? Take it as if you never heard it before. Okay?
Yes.
Now, the derivative of x, d by dx. That means we have to differentiate this x. What is the power? Who was I talking to a few minutes ago? Is it Molemani?
Molemani. Yes, it's me, sir.
Molemani, please
Yes,
explain to both. Please explain to both.
So there's an x, right? X originally has to the exponent 1, right? So when we derive x to exponent 1, we will take the 1 down, then we minus 1 again. So it's going to be x to exponent 1 minus 1.
Minus 1.
Yes, which will be 0.
0.
Then anything to
Anything to the
exponent
power
0
of 0 becomes 1.
Yes.
Say, I hear it.
Is it sinking? We have got x. This x is to the power 1.
Power
as I
1,
said.
yes.
As I said, even your name, Butle, is raised to the power 1. Okay?
Yes.
It's the same with this x. This x is raised to the power 1. Now we take that 1, we bring it in front of x. We bring it in front. We're not bringing it down. We bring it in front of x.
Yes.
We take that. This x is to the power 1. We take that 1, we bring it in front of x. And then that 1 is an exponent. To that exponent, we subtract 1. Okay?
Yes.
Meaning it's x to the power 1 minus 1.
Minus 1, yes. 1 minus 1 is 0.
1 minus 1 is 0. So we have got x to the power 0.
0. And anything
x to the power 0 is 1.
Is 1. Yes.
We multiply by that 1 that we brought in front of x.
I hear it, sir.
Thank you.
Thank you, Mulemo. Thank you, Diketo.
Thank you. You are welcome. We are family here. We are here to help out each other. Now, let's look at these examples. Number 1, differentiating f of x, which is equals to 10x to the power 8. They say it gives, okay? Another way of writing it is f prime of x. Okay? Take that 10, you bring it in front, you differ, because it's a constant. I'm repeating. That is the reason that 10 is in front of d by dx.
Yes, yes, sir.
And then we have got that x to the power 8. Now, to that x to the power 8, we bring 8 in front, okay? Then to that 8, which is an exponent, we subtract 1. That's why we have got 8x to the power 7. Do we agree? Okay.
Yes, according to the power rule. You see, I said it must sink in. Thank you, sir.
Yes, then we multiply by that 10. That is why our answer is 80x to the power 7. Can anybody follow this?
Yes, sir.
Okay. Now let me see. Who is here? David, David, are you here? Oh, I think you said David is gone, eh?
Yes, sir.
David is gone. Digezo, are you still here?
Yes, I'm still here, sir.
Thank you. Francis, are you still here?
Yes, sir, I'm still here.
Thank you. Faima, are you still here? Faima. Faima. Okay. Let me scratch out Faima. Mulemani, you are still here with us, no?
Yes, sir.
Thank you. Collins, are you still here?
Yes, sir.
Thank you. Michelle, are you still with us? Michelle. Michelle left. Okay. Scratching out. Margaret, are you still here?
Yes, sir, I'm still here.
Thank you. Bongani, are you still here?
Yes, sir, I'm still here.
Thank you. Butle, you are here, no?
Still present, sir.
D'Angelo, are you here?
Yes, I am.
Okay, thank you. Now, let's all of us look at number 2. They say to differentiate f of x, which is equals to 1 over x squared. We first simplify to get f of x equals to x to the power minus 2. Can anyone explain why they wrote f of x? Do you see? They say f of x is equals to 1 over x squared. But now they say we first simplify to get f of x equals to x to the power minus 2. Can anyone explain to me why they wrote it in that way?
So because it's easier to work with, sir.
Who's talking?
It's Collins, sir.
Collins, yes, Collins.
Sir, because mainly when it's easier to work with, because from what I remember, the standard rule is that when anything is to the power of a negative number, it becomes a fraction, which means that you can actually reverse it. Any fraction can be just simply reversed into a negative power.
I don't know. I understand what you are saying. I don't know whether everybody here hears and understand what you are saying. Please ask them whether they understand what you are saying, Collins, or not.
Guys, do you understand what I'm saying?
Yes, we do.
Yep, I do.
No, can you please repeat for me?
Any number to the power of a negative number becomes a fraction, which means that any fraction can be reversed to become a number to the power of a negative number. Does it make sense, or do I need to think?
Oh yeah.
Yes. So basically, they were just converting the fraction into a whole number.
Yeah.
Because we're working with powers basically. So they basically just reverse the fraction to get negative cube in a sense, negative cube, which is a number we can work with.
Okay. Thank you, Collins, for the explanation. Is everybody now on par with what Collins has said? Thank you. Silence means consent. Now, let me ask you to differentiate f of x, which is equal to x to the power minus 2. Did you get that?
Yes.
I'm asking you to differentiate f of x is equals to x to the power negative 2. When you are done, when you've got an answer, you don't say your answer. You just mention your name. Then by so saying, then I'll know that you are finished. I know that's why I was calling out your names. I know we've got DKs, we've got Francis, we've got Mulemani, we've got Collins, we've got Margaret, we've got Bongani, Butle, and D'Angelo.
Muleman.
You say Muleman, meaning you are finished, eh? You've got an answer for me.
Yes.
Thank
Margaret.
you.
I do too, I think.
Margaret, who? D'Angelo. D'Angelo?
Yes, yep.
Okay, thank you.
Bongani as well.
Bongani.
Digezo.
Digezo. Okay, is morning. Sorry? Francis.
Yes.
Francis, yes. Butle, we are waiting for you. NDK, we're waiting for Butle and Collins. Are they still with us?
Yes, Collins.
Collins, are you finished? Or are you still working it out?
I called out my name a while ago.
Have you got an answer for me?
So the question, repeat the question. So I think I cut at first.
Do you see my screen? Collins, do you see my screen?
Yes. Wait. Yes,
Collins,
sir.
can you see my screen?
Yes, sir.
Okay. Do you see number 2?
Yes, sir.
They say differentiate f of x equals to 1 over x squared. Do you see that?
Yes, sir.
Then, comma, we first simplify to get f of x equals to x to the power minus 2. Do you see that f of x equals to x to the power minus 2?
Yes, sir.
Yes. My question is, what I'm requesting you to do is to differentiate f of x equals to x to the power minus 2.
Okay, I'm done.
Okay, Collins is finished. We're waiting for Butle. 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 Is Butle still with us?
Sorry,
People,
sorry, sir. Sorry, sir. I just put a note to say I'm just dealing a work issue quickly. I'll be back. Sorry, I just put a note on the chat. Sorry about that.
Okay. Now let me go back. Moleman, what did you get, my brother, as an answer?
It should be minus 2x to exponent minus 3.
Yes.
Margaret, what did you get? Okay, I heard you, Molemani. Margaret, what did you get?
Minus 2x to the power minus 3.
I heard you. D'Angelo?
I also got minus 2x to the power of minus 3.
Bongani? Bongani?
I also got minus 2x to the minus 3.
Yo, Digezo.
I got minus 2x to the power of minus 3.
Are you people sitting together? You are copying something. Yeah, you are just copying incorrect things from each other. Francis, please help out. What did you get?
It's a tricky one, but I got 2x to the power negative 3.
What?
2x to the power -3.
That's Francis, ne?
Yeah, that's me.
2x to the power -3.
Yes, sir.
Okay, I heard you. Collins.
So I got -2x to the power -3.
Collins, please help Francis.
I'm back. Sorry about that.
Okay, you're welcome. Have you got an answer for us, Butle?
Yes. I got -2x to the power -3.
Okay, thank you. Francis.
Yes, sir.
You said you've got 2x to the power -3, ne?
That's what I said, yes.
Yes, that's what you said. Yes, I heard you clearly.
Yes.
There is something that is missing there.
It's a negative, I know.
What
now.
did they do with the negative, say? Where did they put the negative?
-2.
Yeah. Yes, Francis, we need that negative.
Yeah,
Okay.
no, I had two possibilities, so I just chose the one, but I understand where they got the negative from.
Wait, is
You
the
see,
negative
so now
two right?
Now there's witchcraft, you see.
You bring the exponent in front. The exponent is -2. You take the -2, you bring it in front, then to the exponent, you -1. So it becomes -2 x to the power -3.
Yes, sir.
Yes, Butle, that's where the witchcraft is coming in. Now, where was I? Oh, okay. Yes. Do you see the answer? -2x to the power -3. Do we all agree on that one? We seem to agree. Or alternatively, you can bring that x to the power -3 below, then it will be -2x to the power 3. Okay. Do you see it?
Sorry, I didn't. Please repeat it.
I'm saying we know that our answer is -2x to the power -3, but you can bring down that -3. You can write this whole thing as a fraction. So that x to the power -3, when you bring it down, when you write this whole thing as a fraction, so it becomes -2 over x to the power 3. Someone
sorry
did explain it. Was it Collins? Collins, is it you explained that part?
Yes, sir. Yes, sir.
Yes. Yes.
Okay.
That's
I get it. I get it. Sorry, sometimes the fraction part it throws me off a bit, but I do understand. Thank you.
okay.
Yet.
The derivative of f of x, which is equals to x squared plus 7x plus 5. Do you see that?
Yes.
Please take that as a homework. Tomorrow when we meet, we'll start by checking your answer for the derivative of f of x, which is equals to x squared plus 7x plus 5. Okay. Can we agree on that one?
Yes, sir.
Thank you.
Yes.
Yes, sir.
Thanks. Okay.